All right, let's dive into something pretty mind-blowing today. We're talking about a new AI called Dr. Zero. And the wild part? It teaches itself to become an expert with literally zero human training data.
So let's start with the big question, right? The one that pretty much everyone in AI is trying to answer. How do you actually make an AI model smarter? How do you make it, better? And for years, the answer has been simple, almost brutally simple. You just drown it in data. We're talking oceans of the stuff, gigabytes, terabytes, petabytes, all of it carefully curated by humans. I mean, that's been the secret sauce for the entire AI boom.
Okay, but what if that entire playbook is not the only way? What if an AI could get smarter all on its own without a single piece of that human-made data? To really get why this zero data thing is such a game changer, we first have to talk about AI's biggest problem. Its crazy, insatiable hunger for data. I mean, really think about it. Every single big name AI you can think of was spoon-fed a mountain of data that humans had to sort through and label. And that process, it's not just slow, it is unbelievably expensive. This data dependency is like a giant wall. It stops a lot of people from building powerful AI, and it's a total dead end for research in areas where you just don't have a lot of data. Like for super rare diseases or really specific scientific fields.
So let's introduce the star of our show. This little guy is a base AI model. It's got the raw potential, but right now it's staring up at that huge data wall we just talked about. The big question is, how on earth is it supposed to level up?
Well, the answer comes from a totally new approach called the Dr. Zero framework. And the core idea is, well, it's pretty wild. It's an AI that literally teaches itself. The official term for this is data-free self-evolution. And believe me, it is a true paradigm shift. Think of it like this. Instead of waiting for a teacher to give it homework, the AI writes its own pop quizzes, tries to solve them, and then grades its own work. It's basically building its own personal, ever-changing school from scratch. But here's the really clever part. It's not just one AI talking to itself in a room. The Dr. Zero system is more like a partnership. It's two AIs working together, where one takes on the role of the teacher and the other becomes the student. They basically evolve together.
So let's look at this teacher-student dynamic, because this is really where the magic happens. The researchers call them the proposer and the solver. Okay, so the proposer, that's our teacher. Its whole purpose in life is to invent new, tricky questions, or quests, to stump its partner. And the solver, that's our student. It takes those quests and has to figure out how to answer them, usually by using a tool like a search engine. And here's the cool part. As the student gets better, the teacher is forced to come up with even harder problems. It's this constant back and forth that pushes them both to get smarter. And what's so cool about this is that the teacher and the student, they're not two totally separate AIs. Nope. They actually start out as identical twins, exact copies of the very same base model. They only grow into their different roles as they start training each other. So, how does this all work in practice? Well, it's all about a really elegant and powerful feedback loop. Okay, here's how it goes down. Step 1, the teacher, the proposer, dreams up a new, tough question. Step 2, the student, the solver, goes off and tries to find the answer. Now, step 3 is crucial. Depending on whether the student succeeds or fails, the system generates what's called a reward signal. This is the feedback. The teacher learns if its question was maybe too easy or way too hard, and the student learns from its own success or failure. And finally, step 4, both of them use that feedback to level up. Then the whole cycle starts over, but this time they're both a little bit better.
Now, you're probably thinking, man, that sounds like it would take a ton of computer power, and you wouldn't be wrong. But the researchers came up with a super smart shortcut. It's called HRPO. The analogy here is perfect. Imagine a teacher grading homework. Instead of going through every single answer one by one, which takes forever, they group similar problems together. Grade all the addition problems at once, then all the multiplication problems. This clustering makes the feedback process way faster and slashes the computing power needed. Okay, so the theory is awesome. A self-teaching AI, a super efficient training loop. But the real question is, does it actually work? Let's see how this self-taught agent did when it went head-to-head with the old guard. So, the researchers threw a bunch of really hard tests at Dr. Zero. The moment of truth. Did it actually work? Oh, it worked. It worked better than anyone could have guessed. Check this out. On a standard test called Natural Questions, the regular AI that was trained on human data scored around 0.327.
Dr. Zero, the one that taught itself, scored 0.397. It didn't just keep up, it blew the competition out of the water. And I have to say it again, it did this with zero human training data. That's just incredible.
And, you don't have to take my word for it. The researchers themselves summed it up perfectly. They said their work proves that complex skills like reasoning and search, they can just emerge on their own purely through this self-evolution process. And there you have it. Our little base model has completed its transformation. It went from a blank slate to a seriously powerful agent ready for anything, and it did it all on its own. Okay, so let's step back for a second. What does a breakthrough like this actually mean for the future of AI? All right, let's wrap up with the big takeaways here. First, and this is the big one, we now know that AIs can reach elite levels of performance without human training data. That's huge. Second, this whole teacher-student or proposer-solver idea is a seriously powerful engine for building systems that get better on their own. And finally, this completely upends the old more data is always better philosophy. It cracks open a whole new door for AI research. And that really leaves us with a mind-bending question to chew on. For so long, an AI's potential was basically defined by the data we gave it. But if an AI can now write its own textbook, its own curriculum, one that's perfectly customized to its own needs at every single moment, well, what are the limits then? What can't it learn?
Have you ever felt like you're talking to an AI that has the memory of a goldfish? We're all trying to use these amazing tools, but that feeling of starting the conversation over and over again is a huge barrier. Well, today we are diving into some really cool new research that's trying to fix exactly that, giving AI a memory that actually works.
I mean, it's a frustration we've all felt, right? You spend time carefully explaining a project, your goals, what you need, and then just a few prompts later, poof, it's all gone. You have to start from square one. And this isn't just annoying, it's the one big thing holding AI back from being a truly useful partner for anything complex.
So why does this keep happening? Well, the culprit has a technical name, the finite context window. But you can just think of it as the AI's short-term attention span. And honestly, it's surprisingly small. Once a piece of information slips out of that window, it's just gone. Forever.
And because of that limitation, any complex, multi-step task, like planning a big trip or working on a coding project for a few days, it's like hitting the reset button on your conversation every single time. The AI just can't build on what it learned before, which makes it super inefficient, and a lot of the time, not very helpful.
So to fix this, developers have basically tried giving agents two kinds of memory. You've got your short-term memory, or STM. Think of this like the sticky notes you have all over your monitor. They're right there, super fast to look at, but you run out of space real quick. Then you've got long-term memory, or LTM, which is like a giant filing cabinet. It can hold tons of information, but it's slow and kind of clunky to dig through. The real challenge has always been getting these two to actually talk to each other.
Let's take a quick look at how engineers first tried to, basically staple these two memory systems together. And the results? Well, let's just say they were pretty clunky.
Okay, so the first approach was this trigger-based thing. Just imagine a filing system that's on a timer. It only saves documents at 5 p.m., period. It doesn't matter if you have a brilliant, time-sensitive idea at 9 in the morning. Too bad, it's not getting filed away. As you can guess, this was way too rigid, and it missed a ton of important stuff.
So, when that didn't work, the next idea was, hey, let's just hire a separate AI to be a memory manager. But the problem was, the main AI that you're actually talking to still couldn't interact with it. It's like having a librarian in the back room who never ever speaks to the clerk at the front desk. They called these systems loosely coupled, which is just a fancy way of saying they were broken and really, really inefficient.
So yeah, obviously these Frankenstein solutions just weren't cutting it. The core problem was still there. The AI itself had absolutely no control over its own memory.
And that is where things get really interesting. Researchers came up with this unified framework they call Agentic Memory, or AgeMem for short. And the idea is so simple, but it's totally revolutionary. What if the AI agent could decide for itself what's important enough to remember, what it should forget, and when it needs to pull up its own memories?
And honestly, this quote just nails it. The breakthrough isn't about building a bigger filing cabinet or faster sticky notes. It's about giving the AI a toolkit and, crucially, the intelligence to actually use that toolkit on its own.
So what's in this new memory toolkit? Let's take a look. AgeMem gives the agent 6 key actions. For its long-term memory, that filing cabinet, it can add new info,
update things it already knows, or delete stuff that's obsolete. And for its short-term memory, the sticky notes, it can retrieve important facts from the filing cabinet, summarize a long chat to get the main points, or filter out all the distracting noise. For the first time, it's in complete control.
But, just handing over the keys to the car isn't enough, right? You got to teach it how to drive. So the researchers designed a special training program. They basically sent the AI agent to memory school.
So they put the agent through this really smart 3-stage training program. First up, LTM construction. It learns to figure out what's actually important enough to file away for later. Then, STM control. It learns how to cut through the noise and keep its active memory clean and focused. And finally, the big test, integrated reasoning, where it has to use both memory systems together to solve a really tough problem.
So, the big question is, did the agent graduate with honors? Did all this training actually work? Well, the researchers put the new AgeMem agent head-to-head against a basic AI with no memory system, across 5 really tough challenges. Let's look at the report card.
And while the results are, well, they speak for themselves. The standard agent only managed to succeed about 28% of the time, but the AgeMem agent, with its new memory toolkit, jumped all the way up to almost 42%. That is a massive leap. That's the difference between a tool that's frustrating and one that's genuinely helpful.
I mean, look at that. That's a nearly 50% jump in performance. This isn't just a small improvement. It's a huge step forward in how effective these agents can be.
But here's what's really cool. It wasn't just about getting more tasks right. The AgeMem agent also built a better quality long-term memory. It actually learned how to save information that was more relevant and useful for the future. It wasn't just working harder, it was working smarter. And if that wasn't enough, it's also more efficient. Because it learned to summarize and filter its own thoughts, the agent actually used about 5% less data to process. And in the real world, at scale, that's a huge saving in compute costs, which is a massive deal.
Okay, so this is about way more than just a clever bit of research, right? This points toward a future where our conversations with AI are just fundamentally different, fundamentally better.
Think about it. What would it be like to have an assistant that actually remembers you, that knows your preferences from weeks ago without you having to repeat yourself? Imagine an AI that could manage a complex project with you for a whole month and never lose track of a single detail. This is the groundwork for an AI that doesn't just respond, but actually learns and grows with us.
It really makes you think, doesn't it? From tackling huge scientific research projects to creating a tutor that's perfectly tailored to you, what kinds of problems could we solve with an intelligent partner that never ever forgets what truly matters? It's a future that, thanks to work like this, is getting closer every single day.
All right, today we're diving into a new framework called SimpleMem, and it promises to solve one of the biggest, most frustrating problems in AI by giving it something it has desperately needed, a perfect, lifelong memory. You've totally been there, right? You're deep into a conversation, maybe you're working on a complex project, and then bam, the AI has absolutely no idea what you were talking about just a few minutes ago. It is just so frustrating. This is what researchers call AI's goldfish memory, and it's a huge barrier to creating AI that's actually, helpful. But a new approach, one that's inspired by our own brains, might be the breakthrough we've all been waiting for. So what's really going on here? Why does AI have such a bad memory? Well, it all comes down to something called a context window. You can think of it like the AI's short-term memory. It can only see a fixed amount of the most recent conversation, and anything that falls outside of that window, it's just gone. Poof, forgotten. And the consequences for us? They're huge. You end up repeating yourself over and over. The AI gets completely lost if you give it a multi-step project. And worst of all, it can't learn from anything you've told it before. All that old, redundant information actually makes its own memory worse over time. Now look, people have tried to fix this. It's not a new problem. But the old solutions were, let's just say, clunky and really inefficient. They basically forced you into this awful trade-off between performance and cost. The first idea was just brute force, just save everything. But that floods the AI with tons of useless conversational fluff. The hellos, thank yous, all that predictable stuff. The other idea was to use the AI itself to constantly summarize the chat, but that was painfully slow and super expensive. So here's the bottom line. Neither of these methods could create an AI that was both smart enough and cheap enough to actually run continuously for a long time. We really needed a new way of thinking. And that is where SimpleMem comes in. It is this really elegant new framework that doesn't just try to brute force memory. Instead, it gets clever.
It mimics how biological systems, like our own brains, manage information.
Okay, so at a high level, this is what the whole system looks like. I know, it might look a little complicated, but it actually boils down to this surprisingly simple three-stage process that filters, organizes, and pulls up memories with incredible efficiency. So let's break it down. It's a really powerful flow, and it's pretty intuitive. First, it filters out all the useless noise. Second, it consolidates what's left into useful knowledge. And third, it adapts how it retrieves that information based on exactly what you're asking it.
Okay, so think of stage one like a really smart doorman for the AI's memory. It uses this special filter that's basically trained to spot new and surprising information. It just throws out all the fluff and only lets the really important stuff get inside, which it saves as these neat little memory units.
Next up is stage 2, and this part acts like a librarian. It's always working in the background, organizing those memory units it just saved. It finds related pieces of information, like say all your chats about a specific project, and it bundles them together into a higher level summary. This is actually a lot like how our own brains form long-term memories. And finally, we get to stage 3, the smart assistant. Now, when you ask the AI a question, it doesn't just dump its entire memory. First, it figures out how complex your question is. If it's something simple, it just pulls a few key facts. But if it's a really complex question, it'll grab more details and those abstract summaries it built earlier. This adaptive approach is what saves a massive amount of energy and money.
So this brain-inspired design sounds really cool in theory, right? But does it actually work? Well, the results are, they're pretty staggering actually. Let's look at the numbers. First, let's talk efficiency. Compared to that old method of just saving everything, SimpleMem uses 30 times fewer tokens. Now, tokens are the basic currency that AIs run on, so that is a huge reduction in cost. It's what makes having a long-term AI companion actually affordable. And get this, it's not just cheaper, it's actually smarter. SimpleMem boosted performance by over 26% compared to the very best memory model that came before it. So you are getting a huge jump in accuracy for a tiny fraction of the cost. This chart from the research paper really says it all. The goal, the absolute sweet spot, is that top left corner. That's where you get the highest possible performance for the lowest possible cost. And as you can see, SimpleMem is sitting right up there, hitting that perfect mark. Let's make that even clearer. Look at this table. If you compare SimpleMem to the previous best system, Mem0, the difference is just wow. SimpleMem gets a way higher performance score. We're talking 43 versus 34, while using almost half the tokens. It's a slam dunk. It wins on every single front. Okay, so let's zoom out. Beyond these impressive numbers, why does this really matter? Well, because giving AI a perfect, efficient memory fundamentally changes the game. It changes everything we can do with it. The researchers themselves put it perfectly. The goal is to improve information efficiency. In other words, they're trying to get the absolute most intelligence out of the least amount of data. And by cracking that problem, they've unlocked the potential for truly lifelong AI agents. Just imagine it. An AI assistant that actually remembers your vacation plans from 3 months ago. An AI project manager that can handle a year-long project without forgetting a single detail. We're talking about personalized tutors that track a student's progress for a whole semester. Or video game characters with genuine, evolving memories. The possibilities here are just enormous. And all of this leaves us with a really fascinating final thought. We've spent all this time trying to get AI to remember, but once it has a perfect memory of every single thing we've ever said to it, the question kind of flips back to us, doesn't it? What will we choose to share with it then?
In the world of AI, for the longest time, the race has been all about one thing: size. Bigger models, more data, more computing power. But what if the future of AI isn't about being bigger, but about being smarter? Well, today we are diving into a really fascinating new chapter from Ministral AI that's challenging that whole philosophy.
All right, so here's our roadmap. We're going to start with what I'm calling AI's billion-dollar problem. Then we'll get to meet the new Ministral family of models and uncover their secret sauce, a technique called Cascade Distillation. After that, we'll see how they create these specialized little thinkers, look at some really impressive results, and finally, we'll talk about why this whole shift towards efficient AI matters so much.
So, for the last few years, the main strategy in AI development has been pretty straightforward. Just scale everything up. All the big players are locked in this race to build the most massive models imaginable.
The thinking has always been that sheer size is the only real path to getting more and more intelligent. Just throw more compute, more data, and more money at the problem.
But this whole approach forces us to ask a really critical question. Is this sustainable? I mean, really? As the costs just keep skyrocketing and the environmental footprint gets bigger and bigger, is this bigger is better approach the only way forward? Or does it just create a massive barrier to entry, making cutting-edge AI available only to a handful of tech giants?
And just to give you a sense of the insane scale we're talking about, a model like Llama 3 was trained on 15 trillion tokens. You can think of a token as a piece of a word. It's a number that's almost impossible to wrap your head around, and it represents a colossal investment in time, money, and resources. This is exactly the trend that Mistral is trying to break.
So, what's Mistral's answer to this massive challenge? Well, instead of trying to build another monster model, they've come up with a whole new family of them, all designed around a completely different principle: powerful efficiency.
So, say hello to the Ministral 3 series. And yeah, the name, Ministral, like Mini and Mistral, it pretty much tells you everything you need to know about their whole approach. These things are built from the ground up to be compact, to be efficient, and to be incredibly capable.
And we're not just talking about one model here. It's a whole lineup. You've got 3 sizes, 14, 8, and 3 billion parameters. And you can just think of parameters as the little dials the AI uses to learn. Each of those sizes comes in 3 different flavors: a base model, one tuned for instructions, and a specialist for reasoning. They get their smarts from a larger parent model, they can see images, and, this is a big deal, they are completely open source.
So you're probably wondering, how on earth do you make a small model that can think like a really big one? Well, the answer is in their unique training method, something they call Cascade Distillation. This right here is the secret sauce behind the whole thing. And this analogy is just perfect. Imagine a master sculptor who starts with this huge block of marble. That's the big parent model. They don't just smash it to pieces. They carefully and precisely carve it, refining it down into a smaller but perfectly detailed statue. Cascade Distillation does basically the same thing for an AI, methodically shrinking it while making sure all that valuable knowledge gets passed down.
So the whole process works in this really clever 3-step cycle. First, they prune, or intelligently trim down, the large parent model. Then, they distill all that knowledge into the new, smaller model, using the big one as a teacher. And finally, they just repeat the process, using that newly created 14B model as the starting block to create the 8B model, and so on. It's literally a cascade of knowledge flowing downhill.
This chart is a fantastic illustration of that process. What you're looking at is the model's training loss, which is basically a score of how many mistakes it's making. A lower line is better. Now, see those 2 sharp vertical drops? Bam! Those are the pruning events. That is the exact moment the model is surgically made smaller before it starts learning again, carrying all the wisdom of its parent with it. But just making them smaller is only half the story. The real magic happens with what they do after this initial training. They take these base models and fine-tune them to create specialized thinkers, each one tailored for a very specific job. So you've got 2 main variants to understand here. First is the instruct model. Think of this as your all-around smart assistant. It's fantastic for general conversation and following directions because it's been trained on tons of examples of good conversations. But then you've got the reasoning model. This one is the specialist, the problem solver. It's been trained on data that literally teaches it to think step by step, which makes it a rock star at complex math, coding, and logic puzzles. Different tools for different jobs.
Okay, so the theory sounds great, right? But does it actually work? Can these compact models really compete with their much bigger rivals? Let's take a look at the results because honestly, they are truly impressive.
So right here, we're seeing the 14 billion parameter Ministral-based model going head-to-head with Quen's model of the same size. And on benchmarks that test general knowledge, like Trivia QA, and mathematical skill, like the math test, Ministral doesn't just keep up, it actually pulls ahead. It's already showing that it can punch way above its weight class. Now, this is where it gets really exciting. Arena Hard is a super tough benchmark that basically measures how well a model can have a conversation that humans actually prefer. And just look at these scores. Ministral 14B Instruct is hitting 55.1, leaving competitors like Quen and Gemma way behind in the low 40s. I mean, this isn't just a small win, it's a blowout.
This scatter plot tells such a great story about efficiency. The vertical axis is accuracy, so higher is better. The horizontal axis is how many words the model spits out, so lower is better because it's more concise. Now, you always want to be in that top left corner. And notice where the Ministral models are all clustered? Yep, right where you want to be. They deliver high accuracy without all the extra fluff. That's what peak efficiency looks like.
And that final bit of training, it really makes a huge difference. This chart shows the performance boost they get from the final alignment stage using a technique called ODPO. This step basically just teaches the AI to have more natural, more helpful conversations. That lighter shaded area on top, that's the performance gain. And for the 14B and 8B models, it provides a massive improvement, making them not just smart, but actually great to talk to.
So let's zoom out for a second and just think about the bigger picture. Why does having smaller, more efficient models matter so much? Because this is way more than just the cool technical achievement. It's a strategic shift for the entire field of AI.
So let's tie it all together. The main thing to take away from all this is that Mistral has created these powerfully compact models using a super efficient training method. These little models can compete with, and in some cases even beat, models that are way bigger. And by making them open source, they are helping to democratize access to powerful AI. It really signals a major shift in strategy, away from a brute force bigger is better mindset to a much more elegant one of smarter, not bigger.
And this all leaves us with a really fascinating question for the future. You know, for years, top-tier AI has been locked away in these massive, expensive data centers. But what happens to innovation, to creativity, to problem-solving, when expert-level AI can run on your local machine, accessible to absolutely everyone? That's the future that Minstrel 3 is helping to build.